Right, more live coding. First two announcements. I'm on cat duty. If you hear cat fights in the background, they're just playing. Don't worry. Secondly, all these programs I'm doing are on Sunlearn, right at the bottom. I put up the exercises one day beforehand, so you can do them and then watch the live coding video the next day, or well, whenever you want. So this one's called stacking. I'll read it first. I haven't touched it in years, so we'll see how it goes. Astronomers have made amazing scientific progress, especially if we consider that until very recently, the only information we receive from the rest of the universe is electromagnetic radiation. And then in 2015, we detected gravitational waves for the very first time. So all the other information about space came from light waves, essentially. Taking a picture of a distant astronomical object is more difficult than we might imagine. The images are noisy because there's dust in the atmosphere and between us and the object. But some of this noise can be eliminated by combining many images into one. This exercise shows how this is done in a simplified form. So we are asked to write a program that uses the picture library to read 10 astronomical images of the same object and to combine them into one composite image. Good. And this is known as stacking in astronomy. In our case, all the images will be taken from exactly the same orientation, so we don't have to compensate for angle or focal distance, and they have exactly the same size. Combine the images, and this is the important part, I think. Combine the images by, for each pixel, calculating the average RGB, red, green, blue value, of the corresponding pixels in the 10 input images. Okay, so we have 10 images. We're going to go, and they all have the same number of pixels. All we need to do is iterate over the pixels and calculate the average color, essentially. You will need to use the following methods, but you can use others if you like. So we've actually covered all of these, either in a short video or in some other live coding exercise. Call your program stacking.java. It must take one command line argument, a string x, that tells the name of the image. The input images will be called x_0.png, x_1.png, x_2, and so on, up till x_9. So 0 to 9, that's 10. And write the averaged image to x.png. I may change this because I know that the correct images are also called x.png, so I want to avoid clashes. Your program is not expected to produce any output to the terminal console, so we don't need to write anything else. Okay, that's what we have to do. Essentially, read 10 images, average them, write them to a different image. And we'll be using these commands. And then here are the raw input files. So there's 4 zip files with 4 sets of 10 images each of these different objects. And then these are the kind of a real image of that object. And we have to compare that. Okay, fine, let's do that. So I'm going to speed this up just to create the project and all that.
First, we'll start by downloading all these images. Okay, right, download as save.
Right, so this is what these images look like. They're pretty fuzzy. There are lots of artifacts in the images, but that's typical of these kinds of pictures. And they're all different. But our aim is to achieve something like this. So let's see how close we can get to this. So I'm going to go over here, source, and I'm going to create a new Java class, which I'll call stacking, and finish main. Okay, right, so I'm going to start by storing the file name in a local variable. Not really necessary, but I think I like that. Then I'm going to I'll create an array of those pictures. So pics, new picture 10. Did this the wrong way, right? Good. So this is an array, but it doesn't know picture. Let's import from Princeton. Okay, and I'm going to load them. I0, I less than 10, I plus plus, and pics I, the ith picture. And if you remember from last time, the way to create a picture is to say new picture and give it a file name. And the file name I want is images slash, and then the X, so that's the file name, plus the underscore, plus I, which will be an int, but Java will add them together as strings, and .png. Okay, I think that'll load all 10 of them. Then I want the width and the height, because I want to create a new picture that will actually contain the final averaged image. So the width will be, now they're all supposed to have the same width, so I'll just look at pics0.width and pics0.height. So I take the very first image and I use its width and height because they're all supposed to be the same. And then I'm going to have a variable. Oh, now I'm going to create the target, the final picture. So I'll call it final. No, I can't call it final because that's a Java reserved word. I'll call it destination. New picture, and this time I'm going to create a picture with a width and a height. There we go. W and H, that's already correct. And now I'm going to average or iterate over all the rows. And for each row, I'm going to iterate over all the columns in this row. X starts at 0, goes up to the width, X plus plus. Okay, and now I need to average the red, green, and blue components. So we've done averages many times before. I'm going to have a total R, which starts off at 0, a total G, which starts at the green component, and a total B, that's a blue component, starts off at 0. And I'm going to iterate over the 10 images. 10 I plus plus. Okay. And I'm going to get the color at this picture, the ith picture. Get will get me the pixel color, X and Y. We've done this. I need to import color. Import, good. I'm going to add its RGB components to the total. So total R plus equals color.getRed. And the same for the other two components. G and B is get green and get blue. Okay, right. So now for pixel x, y, I have gone through all 10 images and added up the components. So I've got the total R, total G, and total B. And I'm going to put the average value in my new picture dest. So dest.set x, y, and I'm going to make a new color that is total R divided by 10, total B divided by 10, total, oh no, gotta be so careful, total B divided by 10. That looks right to me. You know, sometimes it's harder when you think about it too much. I'll look at this again because I'm not sure if it's right, but I'll look at it again. And finally, I'm going to save, and we've looked at this as well, into images and file name, and I'll call it _f for final.png. Okay, let's just have a looky see if this is correct. This is my main routine. I read the file name from the command line. I create an array of pictures, 10 of them, and then for each of them I load it up using this new picture command. Or it's a method I'm calling really. And I give it images slash, and the directory is called images, yes. The file name _I, which goes from 0 up to 9, .png. Is that what the files are called? Karina 0, yes. Cool. So now I have all the pictures in the array. I take the first picture and I take its width and height, and I use that to create a new picture, which will be my combined, my stacked image. I iterate over all the pixels in that picture, or in all the pictures. I'm going to keep a running total of R, G, and B. For all 10 pictures, I get the pixel color, I add the components to my total R, G, and B, and when I'm done, I use the average of R, G, and total R, G, and B to create a new color, and I set that as the pixel value at X and Y. And finally, I save this to file name F. Okay, right. It seems all right to me. I'm going to save, I'm going to run, and I expect an error because I did not give the command line argument. But I'm going to close, I'm going to make that small again. No, like that. Run configurations, stacking, yes. Arguments is $string prompt. Apply, and let's run it. I'm going to start off with Karina. I wonder how long this is going to take. Oh, I should have printed done. Never mind. We'll see when it. I'll open up the console. Oh, it stopped. Okay, yeah, that's very quick. Eclipse does not show this new file because it's a little slow when files change, and I need to refresh. Let's just scroll this up a little bit so you can see. Right click, refresh. I could have pressed F5. Ah, and there's Karina. Open it up. Get rid of that. Oh wow. Oh wow. Okay, so that's my program. We'll just move that here. So that's the Karina F that my program produced, and this is the true image. You can't see the difference. That is amazing. I don't remember it to be this good. Oh, excellent. Good. Right, and that's the whole program done.